Hello and welcome to Arcserve Unified Data Protection Sizing Scaling Best Practice Review. My name is Gary Sussman, Principal Consultant here at Arcserve. Today is part two of our architecture elements and resource requirements. The first part, we already discussed the Unified Data Protection Console and how we can manage the solution. We began discussing the Recovery Point Server, or RPS, as a second component. Today, we're going to further discuss the solution for the RPS, how to size it accordingly. The RPS, the Recovery Point Server, is our backup restore server in our solution. It requires minimum about a gig worth of memory. To run the RPS, remember, is an inline solution, does both the inline source side global dedupe, so make sure you have the right resources. Since it's a backup server, we want to make sure that it's sized accordingly. We have a further course to discuss sizing the RPS, but just keep in mind, it's all about the right components and the size of the server. It really depends on the IOPS. For backups, we can require a SSD in some cases. If you don't have enough memory, SSD will allow you to store the hash and lower that requirement. So backup speeds, where these resources, whether it's on the network, local disk, all that doesn't matter. So that's something to keep in mind. So make sure, for the correct backup speed, number of recovery points, RPO really defines what your environment will be. Also for restore, where and what we're restoring from doesn't matter. Again, it all depends on good IOPS. Restore heavily depends on index. So make sure that if you have a smaller block size, make sure you have enough resources to handle SSD, for example, can be used accordingly. The smaller this block size potential, the longer the archive to tape. So keep that in mind. The smaller the block size, the further time it needs then to rebuild, let's say to copy, to archive. This rehydration time takes quite a bit of time depending on your resources. So in certain environments, you may have to increase your block size to maintain a certain recovery time objective. The index, again, is location. Typically, people, again, require that. With dedupe, it allows us to index data we've seen already. So deduplication globally and source side, hashes benefit. Indexing also helps out as well. The higher dedupe ratio, again, the more disk I/O that may be required, the more spindles, things like RAID, all helps with these types of solutions. Now let's talk about some general architecture sizing for the RPS. For our CPU, typically 2 to 4 active nodes per core is required. We can typically if you require encryption, make sure that the CPU supports it. It really depends on the concurrent backups that you're doing. Typically, the default value for concurrent backups is 4 by default. You can increase that size, so keep that in mind. And more backups, the more processing. So 2 to 4 concurrent active nodes per core is typically required. Memory, we require either pure memory or SSD mode with our RPS memory operation. The server will need ample amount of memory to run, of course. Typically 8 for the console, 8 for just the RPS if it's combined, so 16. But you need further more memory, of course, for backups to run, processing, etc. So make sure you have enough resources and memory to allow for this process. Using SSD further helps again. Speaking of SSD, this is how we can lower the memory on the RPS server by utilizing the hash at this destination. The smaller blocks, the more advantageous is to our RPO and the size that we're going to back up. For SSD, there are a lot of different types out there. It's really about the read performance on our product. We put blocks in order in memory before we write to SSD. So it doesn't take a whole lot, but here's some examples of some SSD that we would recommend. For the location now for storage, SSD, as I mentioned, is typically for small environments, you can use a memory, but typically on SSD, we recommend. So the hash destination is typically set aside on this SSD. It's important that we have the right type of SSD. There's many types out there. Uh, we want to make sure that we can maintain the right type of IOPS for a long period of time. Our calculator that we'll talk about in another episode discusses how to size the SSD accordingly. Make sure it's enterprise or not just the standard home version SSD. Make sure it has a proper IOPS to stabilize for a long period of time. Make sure it has enough space. There's no issues with garbage collection slowing down the drive. As you delete files, it's going to take up the same space as your normal data. That could be an issue. So keep in mind the type of SSD when you use the solution. So SSD's location, you can use memory for that, or hashed SSD drive. Also, we have indexing available. Indexing is another location for our deduplication. We can utilize typically local disk, but for larger environments, this is an important destination. So typically, we try to recommend RAID. Provides a little bit for tolerance. The hash is the only destination that can be rebuilt, so it doesn't need a whole lot of fault tolerance. But these other destinations, we really need to think about fault tolerance. So it's really, how much backups and whether we're archiving really depends on this role. Speaking of RAID, make sure we have a decent RAID controller with the amount of cache that allows us to sustain the right type of performance. There's many types of RAID out there, so consider your investment, what type to match. The advantages is fault tolerance. The spindles provide definitely a better process, so just keep that in mind. Other things to consider is block size, as I mentioned earlier. The larger the block size, the less resources that are required, but potential more disk for backup is required. Opposite, the smaller the block size, for example, 4K, great for dedupe, so less disks, but more resources, memory, or SSD will be required. If your RTO, is important, so when the disaster occurs, how quick you want to get back up and running is important to you, then that will indicate the investment, the type of drives, the type of RAID. So increased RPO, increased investment, utilizing larger blocks, other things will help in restoring faster. So the RPS with these locations, we create what we call data stores. There's no really limiting factor to data stores. So it's really all about performance. Other things to think about is to have idle time for merging for other processes. If you're running the backups 24 hours a day, then you're not giving enough time for things to settle down, like merging and other processes, cataloging, etc. So do set time a day or a week to perform maintenance with these tasks. Other things to keep in mind, continued, as I mentioned, maintenance, not only with the data store to help grow, make sure you have enough time for that operation, but also all our performance will also benefit with maintenance. We have a tool to help you with managing manually uh, different things like rebuilding hash, sort of verifying the environment, purging your data. This tool will be further discussed in another course. But although, again, maintain the environment, make sure that resources are used accordingly. Also, outside the UDP environment within your RAID infrastructure, the Windows operating system, the disk fragmentation, all the things we need to think about. And the solution can help as well, help throttle, make sure you can run backups outside the normal business hours. So this data store with all these locations we can build. When we enable dedupe, remember we need 4 locations. The destination data store is where we're going to back up, restore if we need to our recovery points. That typically is on local disk, network disk, SanDisk. The other 3 are typically for dedupe. So the data dedupe folder, typically RAID 5, 6. Again, nearline. This is where we're storing our unique blocks of data. The index will map out how many times we've seen that unique data. And so typically it's about 10% of the size of the backup you're doing. Again, RAID for faster performance is recommended, especially if you're doing copy to tape or any type of archive. And then, as we mentioned, the all important hash location, where this is the SSD. As you can see on the little diagram here, our console is where we manage the environment. We have our RPS, which, as you see, is down here. We have our SSD drive. Other volumes are mapped out for our data stores. So you can see I have 3 different data stores, maybe segmented for different types of data. It all depends. For every dedupe data store, remember, we require some resources. So it really depends on size, the block size that's used on that data store. You can create multiple data stores on the RPS. Just keep in mind, you can't do our global deduplication across data stores. When we do catalog, we have to create, acknowledgement of files structure. So that takes time and resources. So after a backup can be extended if you decide to create a catalog. If you disable catalogs, then we don't need to create that at that time. Your RTO will be impacted though if you do need to, let's say, restore a file. Catalog then it has to be created then. So running the catalog does take some resources. Also, replication between RPSs. That requires resources to optimize this process. 200 to 250 megs of RAM. Also, per stream that is actually operating requires additional resources. 24 megs of RAMs, depending on whether it's a single console or whichever is doing the read or write performance. Lastly, we have a sync utility that runs also on the destination server. The destination RPS just needs additional 10 to 20 megs. So with the RPS, with our data store creation, with our location, our destination for backups, we can perform our protection, data management. Now I'd like to go through some sizing examples, if you will, based on storage, as we just discussed. I like to discuss this in the good, better, best. So goods is typically for small environments. They're not really worried about redundancy or RAID typically. So fault tolerance is not a really big issue. Cost is, again, a factor probably. So they can configure in pure mode without SSD all the volumes on the same spindle or the same volume. Of course, this is a single point of failure. It's not recommended. I would definitely do replication or archiving the data offline. So just things to think about. Memory, if there's an issue on the server, we can add an SSD and operate in SSD mode. In SSD mode, our hash is now on that destination only, and the other paths are on the same volume. In a much larger environment, a little more resources are available typically. So a better practice would be to have some segmentation. Configure the dedupe data path on one volume, and then the other 3 on the other. I would definitely recommend RAID to give you some fault tolerance in here for if you're doing pure mode. Adding SSD in SSD mode, again, further separates the hash in its own location, and then your other paths as well. So segmentation, more spindles, more performance is the idea in this example. For larger environments, the best strategy, of course, is to provide the best disk IO with separate spindles if all possible. Everything should be configured in their different locations. If you decide to do SSD, you can see how SSD has its own hash destination, and you can configure everything else either in one volume or separate them. It really depends on the investment and type of IOPS that are used. But typically, the idea is to, again, keep all disk IO on separate spindles if needed. Another thing that we can help with resources sort of maintain or adjust parameters is when you create a data store, you can sort of adjust the concurrent active nodes. So think of it as a queue. If you have 8 backups, but only 4 is limited, then the 4 will be processed and the 4 will wait. So concurrent, we can do this. Its default is set for 4, but you can increase the value. If you have great performance and have the bandwidth, then of course you can exceed the concurrent default value. But keep that in mind. You don't want to have a bottleneck and reduce performance because you're doing too much. So just keep that in mind. This is where you can adjust. When we have a proxy server is a server with our agent on it. It performs our backups. Typically, we only recommend 10 concurrent backups on that. You may need more than one proxy otherwise. So enough about the RPS. The last component is the agent. So console, RPS, now agent. Agent is what we deploy. It protects the Windows or Linux system. Here's some lists of CPU again, memory, how much disk is required. So 10 gig is good for a complete installation. An agent just requires 2 minimum. 4 is typically recommended. If you're setting up proxy is a server with an agent on it, performing agent's proxy backups, then 4 CPU, 8 gigs of memory on that. So as you can see, quite detailed what system requirements are needed. The agent, again, needs about 1 gig to run. It has processing. So if you're trying to protect a node, physical machine, virtual machine with the agent, it does require a minimum 2-core 1 gig. A proxy server, if it's doing virtual standby, it not only needs 8 gigs, but if it's doing any conversion of a backup into a virtual host, again, proactive virtual standby, we can provide this transport and conversion, but it needs some processing. Agents process, again, with the proxy, provides a way to provide a way backup out of virtual hosts. We don't have to have an agent inside each VM. We can connect via the virtual disk. So the proxy is a very important piece here. The proxy server must have access to the virtual machine. So if you're on a SAN, make sure you have an HBA. For vCenter, we can do direct transport over your SAN iSCSI LUNs where your virtual disk resides. So be aware for VMware environments where the proxy is. If you have a SAN, again, make sure in order to do SAN-based transport that we have the correct environment set up. Network block allows us to do our network-based backups. So if you don't have expensive SAN, it's fine. Our NBD provides the protection in those environments across the network. Also, keep in mind what type of disk you're using. Some disks, like thin disk on network, has fast performance, where thick disk on SANs. Lastly, I get this question a lot: can you virtualize the proxy? Yes, We utilize hot add as a measure of this transport. This method opens and reads the hot added disk once it's attached. So keep in mind the strategy works with certain types of environments, and make sure you have enough resources as well. Again, typically 10 concurrent backups per proxy. So the proxy is the middleman for all your protection. The console manages everything. So it acts in accessing the virtual disk, for example, is Hyper-V server, also VMware. So how we're accessing these virtual hosts is important. So make sure your proxy has the applicable resources and also has access to the environment that they're stored on. Once the proxy sees the data transport, then sends it to the RPS. This is where we do our source side global dedupe. It's all in line accordingly. The proxy, 8 gigs, 1 CPU again. Again, HiLAD may require more resources inside the virtual host, as you see here. You can have a physical proxy as well as this RPS. The RPS typically is the proxy since it has resources as long as it has access to, example, the host bus adapter to the SAN. In certain environments with raw disk maps or RDMs, you may have to install an agent inside the virtual machine, treating it like physical, basically. It doesn't matter. Our source side inline dedupe will allow us to find unique blocks data just like anything else. So proxies are very important, as you can see here, in order to access, again, based on the size of the virtual environment, how frequent we're doing backups, if we're doing other things on the host. These are some things to consider. You may have to have multiple proxies to get data, especially if you're trying to do concurrent backups. Remember, there's only 24 hours in a day. So for vSphere, current backups also require memory. So in addition to the 8 gigs of RAM, if you're running concurrent jobs, so just keep that in mind. Every job is going to take additional resources. Hyper-V, the same. Now for Linux, Linux requires a server. This acts as a proxy method as well. So we don't have to deploy any other Linux agents, just the proxy Linux server provides the protection. 64 bit, 2 gigs is all that require. 6 gig space. We support many different types of operating systems and file systems. Just like the agentless proxy server, Windows can also act as a proxy to your Office 365 and SharePoint. We can protect the servers, bring that information, so email, contacts. We can then back it up on the RPS. We can set retention, deduplication is enabled. So this Windows proxy requires 2000 R2, .NET Framework 4.0. You must, of course, have the proper credentials to access the Exchange online resources, typically the Discovery Manager root role. Same with SharePoint. The proxy can act as the middleman to get at your shares on your SharePoint website online. So just like email, we can protect your investment in your Microsoft Cloud, bring it back on-premise with this Windows proxy. We also, with the Windows proxy, can protect UNC paths. These are file shares on NAS devices. We do support agent-based Windows NASs, but if you don't want to deploy agent or if it's locked down NAS like Linux, we can protect files, folders across SMB, CIF shares. We can do exclusion, other credentials to protect your systems. Bring it, again, off of these expensive devices. You can maintain long retention deduped on our recovery point server. So backing up your network shares can now be done via this proxy. There is some limitations. You need to have access, of course, read writes, and Typically, we can only do about 128 terabytes of backup per plan. So you can get creative and back up multiple plans, separate the data. That's a whole lot of data anyway to be backing up over a UNC path. We also, uh, without proxy, can protect other systems like NetApp, 3PAR, Nimble. We can do what's called hardware-based snapshots. The idea is why go across network if we can just go to one location, one device, rather than 100 machines communicating. You can see to one device makes more sense. So this is a faster process, more performance. We can do different types of environments, virtual, uh, physical. We can do different types of protocols, iSCSI, NFS, and fiber channel in certain systems. So that's it. Hopefully, you enjoyed or found this beneficial to the second course of learning about the RPS. Again, the RPS is an important piece of the Unified Data Protection Solution. We then further discussed our agent and how we can protect your systems. That agent also can act as a proxy server, so that that agent can act as a middleman to protect many different types of environments. So thank you for your time.